right, hi. Thank you for coming. So my name is Tomel. As a counterpoint to the last talk, this one is not going to be funny at all. We're going to be talking about on-prem. It's going to be depressing. So if you had a good time, this talk is for you. Right out the gate, on-prem. What do I mean by that? Well, as most of you probably know, on-prem stands for on-premise, which used to mean on the customer's premises. In other words, you have a customer, they have an office. In that office is a room where there are servers, and your software is running on their servers. Now, that is a very antiquated way of putting it that is no longer relevant. Your customers are probably not running their own data centers, probably not running their own hardware. They probably don't even lease hardware. They're probably just firing off API calls at Amazon and getting their servers from there. So more likely than not, your customers are actually running on someone else's prem. So I find that a more useful interpretation of on-prem means your software on hardware you do not control. That is kind of the preview. Now let's talk about on-prem. So right out the gate, on-prem always was considered a swear word. 10, 20 years ago, if you were a software developer and your boss came up to you and said, we had a product meeting, we decided we need to go on-prem with this product, you would get chills. You would be afraid for your life, your job, your livelihood, for good reasons, your sanity mostly. And there were very good reasons for that, but it's been a long time, for me anyway. I haven't done any on-prem software deployment in almost 2 decades now. But I recently had the opportunity to. So I just wrapped a project that is an on-prem installation of a software project, and I want to tell you a little bit about it. Why am I qualified to talk about this? I'm a freelance software engineer slash SRE, what have you. I've been around the block for almost 2 decades now. Now, what this means isn't that I'm great at what I do. It means that I'm old enough to remember what software used to be like pre-internet and pre-SaaS. And it also means I spent most of my career building software at first in the traditional on-prem sense, then doing web development for the better part of the last 2 decades. And that means I have a certain perspective that I want to share with you about what on-prem is like nowadays. So, on-prem. Why is it hard? Now, this is a synopsis, but more importantly, it's from the least bad to the worst. So in terms of the release process, obviously, when you're running on someone else's premises, you have a complicated release process. You have customers. By definition, there are multiple parties that are involved in getting your software from wherever it is, GitHub or whatnot, to actually running on a customer's hardware somewhere. The release process, when you're running SaaS, when you're running, doing the things you normally do, the release process generally looks like this. I have a feature, I'm done with it, I committed it, I might need to push a couple buttons, and it's there. That's not much of a process. In on-prem, you have to coordinate. Now you have a release process. You have customers that need to receive the release. They need to install and set it up. It's a very complicated process just by virtue of having multiple parties involved in it. In terms of control, when you're developing SaaS, like we all know and love, you get to control everything. You get to dictate the hardware, the tech stack, the schedule. Everything is yours to command. When you're doing on-prem, it's your customers. They dictate everything. You don't get to control nada. These are the easier problems to solve. The tough ones start now. How many versions of your software are actually running in production right now? Presumably, the vast majority of you, whom I can't see, by the way, are running in a data center somewhere, maybe on Amazon. You have a limited number of versions. Typically, you'd have a production system, a staging version, maybe a QA version, a couple of QA environments. Whatever it is, you have a small, finite set of environments that are actually deployed in the field. On-prem, it might be as many as the number of customers you have, because you can't really control it. Your customers may be running CentOS 5, like was mentioned in the last talk, and there's nothing you can do about it. You just need to support it because that's where the money comes in. Crucially, the staff. That is the most important aspect of it. The people installing and operating and managing your software are not your people. They are your customers' people. To you, they are a third party, which means they are not incentivized in the same way. They don't have the same success criteria. To them, running your software is a burden. They would rather not have to do it if they could get away with it. And that is a profound difference that affects everything you do. So, a very, very quick overview of why on-prem is fundamentally different from the sort of software as a service that we all do today. Why would you do this? Like, why would you actively go and install your system on someone else's hardware if it's that hard? Well, it turns out that if you can get away with doing software as a service, you should. You don't want to run on-prem. Right out the gate, if you can avoid it, don't do on-prem because it's still harder for all the reasons we just discussed. However, in some cases, you just have no choice. So if you're in a tightly regulated industry, like medical devices, for instance, well, maybe you're just not allowed to by law. In some cases, you might have security considerations. So if your software is whatever, the control system for a nuclear reactor, probably, hopefully, although with the last talk, who knows, it's probably not connected to the internet, which means SaaS isn't really an option. You might have physical constraints. So if your software is running on a device somewhere, like a pacemaker, whatever it is, it might not even be able to have access to the internet, right? So SaaS isn't an option. And then there's the usual array of customers with their weird requirements. Notably, some of them simply will not use your service if it's SaaS. They want to own the data, they want to control the data, sometimes for good reasons, sometimes for bad reasons. Whatever the case, you may not have a choice. So, if you're in this position, well, I've got some news for you. On-prem doesn't look anything like it did a decade or two ago. And that's what the rest of this talk is going to be about. Before we can cover how on-prem has evolved and the types of tools that you would use nowadays, though, let's take a second to contrast on-prem with sort of its go-to alternative, which is SaaS. Now, I can't see any of you, and there's a lot of you, which means that there's a good possibility that a lot of you, or some of you, are older than I am, and then more likely a lot of you are younger than I am. What that means is, unless you've been in this industry for a while, you might not have had the experience of living in a pre-SaaS world. What you might not realize is that SaaS was a new concept 20 years ago. Hotmail, Gmail, those things we take for granted are not that old. Gmail as a service, I think, is less than 2 decades old. And that was one of the first major software as a service offerings on the internet. So over the last 2 decades, SaaS became the norm, and a lot of tools have evolved to support and enable that ecosystem. Tools that we did not have in the 90s and early 2000s. Some of those tools include hypervisors or virtual machines, which is basically your ability to take a piece of software, whatever hardware it was developed on, whatever operating system you prefer, and just run it in isolation irrespective of the host. That was a new thing-ish 20 years ago. We have public cloud providers now, which obviously we didn't have 20 years ago. We have containers, right? Docker, the thing we know and love, which is an exceedingly simple way to package your software and actually run it. We have container orchestration, so Kubernetes, Nomad, whatever it is you prefer. They abstract the execution environment, because if your code no longer assumes it's running on Linux or Windows or whatever it is, you just abstract that away with a container, might as well abstract away the fact that you're even running on a particular set of service or in a networking environment. And that's what orchestrators give us. So, the obvious rhetorical question, can we leverage these tools on-prem? Short answer, duh, otherwise I wouldn't be here talking to you. Long answer is, well, you might have guessed it, a little bit longer. So let's consider, before we get into the tools and how they affect or reflect on the on-prem world, let's spend a couple minutes talking about the constraints of a software system as they apply to an on-prem deployment. When you build your on-prem system, there's a few constraints that you kind of need to know right out the gate. The first of these is, do you have any persistent data? Do you store data? Is your system stateful? If your system is stateless, like if you're developing Nginx or some kind of internet accelerator, well, good on you. Your life is so much easier because you don't need to store any data. But more than likely, you do. So that is your first kind of constraint. You have to store data somewhere. Can you run on a single host? If you can, if your software fits on a single physical machine, then your life is much simpler because managing one machine is that much easier than managing many of them. But if your system has to be clustered, well, that is a constraint you need to know right out the gate. Otherwise, you won't be able to design for it. Your customers, where are they? Are they running on a cloud provider? Are they running on AWS or GCP or what have you? Or are they co-located, which is Old English for renting out a server in someone's data center? And can you call home? What are your network constraints? Is your system even capable of taking in messages or emitting data out to the internet? Because if you can't, there are certain things you can't do. If you can't receive a command to upgrade the system, then you can't control it externally. If you can't send telemetry home, then you have to find other ways of generating observability in your system. So those are kind of the really top-level constraints that affect how your system will be constructed on-prem. Now let's talk tooling. And as it turns out, the tooling we have evolved over the last 20 years to support SaaS actually are very interesting for on-prem as well. And we're going to start with the good old Docker. Everyone here knows Docker. I imagine at this point you are tired of hearing about Docker, so I'm not going to talk about it much. I'm just going to say this. Docker is a much more powerful tool for on-prem than it ever was in SaaS. It gives you a consistent way of packaging and deploying and operating your software components. Any given component in isolation is trivially deployable, trivially runnable, trivial to operate, and trivial to instruct and train people on how to do all of those things. Docker makes all of these things really, really easy. Crucially, though, it also composes really, really well with all of the other tools we're going to be talking about. And if you actually package your software components with Docker, well, it turns out that you can reuse that in virtually every single deployment scenario you can think about. So it really is a godsend for on-prem, and that's all I'm going to say on Docker because I know you're tired of it. Here's a tool that does not get the love it deserves. Docker Compose is one of those things that for most people seems to be not particularly useful, but as it turns out, if you're running on-prem and you have the benefit of being able to run within a single host and orchestrate containers within a single host, Docker Compose is the most lightweight, simple, trivial to use, and efficient tool to get the job done. It really doesn't get enough credit. So as long as your system comprises multiple components, but you can fit all of them within a single host, this is a perfect solution for you. Because it also composes really nicely with virtual machine images. Now, VMs were in vogue, were all the, everyone was talking about them 20 years ago. VMs, hypervisors, how they affect software delivery. A lot of that didn't come to pass, and for good reasons, because VMs are big and somewhat unwieldy. But it turns out that they're also an amazing packaging system. Again, assuming you can package a set of components within a single host, you can actually deliver that host as a virtual machine image, which gives you not only a self-contained package, it also gives you an incredibly consistent model for deploying your software. VMs are supported by everyone. It doesn't even matter what your customer is running on. Maybe they're running colo, maybe they're running on a private cloud, or a public cloud, or a hybrid cloud, or a hubris cloud. Whatever type of execution environment your customers are using, they can take in a virtual machine image and make it run. And that makes it a really, really good standard way of delivering your software if you can get away with it. A word about Kubernetes, and really this is the only slide about this. If your system comprises multiple hosts, if you actually have to run a cluster on your customer's infrastructure, God help you. It is hard. It is every bit as hard as you think. It is not something that I'm going to be able to cover in this talk because frankly, you can spend 25 minutes is not going to be enough to spend on this subject alone. It's just too big. So I'm not going to cover it. I will only say that if you do have to run on multiple hosts, then you should probably go full containerized, and you should probably aim to provide some sort of Helm chart or whatever it is that you're comfortable with to your customers so they can actually use one of the managed Kubernetes solutions out there. That is the simplest way to go. Again, huge subject. If you're in this space, you don't need me to explain to you how it's done. You probably know more than I am, and it's probably painful. I'm sorry. There are no silver bullets. If you're running on a public, if your customers are running on a public cloud, your life is so much better. There are so many advantages to having your customers run on a standard cloud environment. So, AWS, Azure, it doesn't really matter. They're all kind of converging on the same set of services and offerings. Critically, you get not only the really, really nice kind of built-in delivery mechanism, which if you're packaging your stuff with VMs, you can even sell them on the marketplaces for those various cloud providers. You also get a really nice story for integration, because your customers are running on a public cloud somewhere. They're very likely leveraging the services of that public cloud to do whatever it is that they do. So they're probably, if they're running on AWS, they're probably storing data on S3. They're probably using SQS for queuing, right? There's a good possibility that you can integrate with those resources. So if your system needs customer data in order to actually do the work that it's doing, which is very likely indeed, offering those integration opportunities right out the gate to your customers is amazing, because your customers already use these things. These services typically provide an identity and access control system that's both a lot better than what you'd be able to come up with on your own, but also it's standardized, and your customers already bought in. That makes it an incredibly easy sell. If you ever try to sell an on-prem system to a customer running on AWS, you will run into the question of, can you just read stuff off of S3? Can you just use IAM? Can you just use, if you're running on Azure, can you just use Key Vault? Well, if you can, then that makes it a much easier sell, because your customers are already bought in. And crucially, you can also leverage these services. So if your system comprises, say, some relational database like Postgres, and you're running on top of Amazon, then just use RDS. Instruct your customers to set up an RDS instance. Done. Everything is taken care of. You don't have to worry about operating it, scaling it. You don't have to worry about backups and retention and user management. All these things are built in, which doesn't sound like much. But if you have to support these things on the customer's premises, that is an incredible boon to you as a software vendor. You also get nice SLA and regulatory guarantees to go along with it, so it simplifies a lot of things if your customer has to, for instance, deal with credit card information. You run in a PCI zone, not your problem. Amazon sort of provides a lot of those services for you, and Azure does, and Google does, and all of the cloud providers do. So this is an amazing way to run if your customers allow it. Monitoring. Well, a lot has changed in that space over the last 20 years as well. So whereas 20 years ago we would have used Nagios or whatever it is we would end up using back in the day, Graphite if you're lucky, nowadays you have a plethora of third-party SaaS monitoring, APM, etc. tools. And the nice thing about the fact that these are managed services and third parties is that if you can convince your customer to use one of them, let alone if your customer already uses one of these services, then now you have a trusted third party to hold on to the data, which smooths out a lot of the questions around who owns the data, where does the data reside. A lot of customers are very sensitive about whether your system, in order to do its work, requires access to privileged or confidential data that the client holds. This gives you a surprisingly pleasant and diplomatic and actually very secure way of saying, hey, we just send your logs, we send our logs to whatever, logs.io, Datadog, whatnot. You can just do the same, or you can just vet this third party that's not us. We're not stealing your data, and it is their business. That makes it a surprisingly easy sell. This ties into the networking constraint, because this only works if you actually can send telemetry out to the internet. whether it's to third parties or to your own servers. If you can't call home, well, really, there's only one way to go about it. If your system cannot call home, if you can't send telemetry over to somewhere, then you're down to log shipping, which is the tried and true way of telling your customers, look, just zip me the log directory, send it my way, we'll figure it out from there. Unfortunately, there's no good news here. There's no easy way to go about it. There are no improved tools that can help you do it. Logging is what it is. It's an experience-based art form, right? Getting good logs is something that comes with experience. There is no easy way at it. But there are some tools that can help you with respect to operating and supporting your software when you actually have these logs. So to start with, again, if your customer is running on a cloud somewhere, sticking your logs in a native object store, like for instance, appending to a log on S3 or something, is a very, very easy way to not only just save the logs and shunt them off somewhere. It also gives you all the identity and access control management tooling that is in the control of your customer. So your customer can safely and securely and in an auditable way provide to you access to the logs that your system saves on their premises, which is something that was a lot harder to do right 10, 20 years ago. You would have to email the logs. There was always the question of, is this secure? Is this auditable? It's a mess. So if you can do that, that's amazing. The second thing is almost all modern day collaboration tools, and I'm going to single out Zoom because that's the one my customers tend to use, but really it's probably true of Google Meet or any of the sort of remote collaboration and communication tools. They give you a nice feature, which is not just screen sharing, but remote control. So if we're on Zoom, I can let you access and control my computer. And that turns out to be an amazing tool for tech support, because the thing that worries your customers most is you having access to their hardware and their data. If their staff is on hand, they're actually synchronously with you on the call, they're looking at what you do. It's not just over the shoulder, right? It's their computer. It's already set up with their secure infrastructure. And you're just doing what needs doing in a way that is visible to them and they can take over at any given point. Everyone is so much calmer, and it saves you those backs and forths of, oh, can you send me the logs? Oh, try to run this command. What was the output? No, I need the whole output, right? All of these conversations just go away. And that is just an incredible experience compared to what supporting on-prem deployments used to be like 5, 10, 15 years ago. Okay, as I mentioned before, I had recently wrapped up a 6-month-long project, which basically was helping a customer take a prototype system into production. And it was an on-prem system, and unfortunately it's defunct. The product did not succeed, it did not find a product market fit, but it does mean I get to talk about it freely. So let's talk about Product X. As I mentioned, unfortunately defunct. It is a multi-component, full-blown production system. It was actually serving paying customers before, unfortunately, the company decided they're not suitably profitable and went out of business. It's a product built in Python 3.9 with all of the usual arrangement of tools you would find in that ecosystem. It leveraged Redis, it leveraged Postgres. It had a static bundle for front-end, like it was a back-end, front-end sort of application. And it had external integration points to various third-party services. Now, all of these things lead us to that set of constraints that I mentioned earlier, which is our customers were running on a public cloud. Initially, we had to support AWS and Azure. Our customers were running in complete isolation, so we were not allowed to call home. We could not send any commands to our own software running on the customer's premise. Critically, though, the system was owned and maintained and used by a team that was not a technical team at all. It was a business analyst team, not stupid people by any stretch, but not technical people either. Certainly not software engineers or SREs. These are basically, my mom and dad, a team of my mom and dad running a production piece of software on their own hardware. And they had an ops department, or IT, if you will, that was incredibly uncooperative. So everything had like weeks of turnaround time. It took us a month to get the server up and running, even though it is on AWS. We couldn't ask for anything. Like any change, any infrastructure requirement, anything you would open a ticket for to your IT or ops department was just right out the window. Not really a possibility at all. Very uncooperative department. So all of these things led us to make some choices. We decided to go with a single host system because we could and because it simplifies things greatly. So to start with, we weren't altogether very concerned about scale. We did end up using Docker Compose for lightweight orchestration. Now, I'd mentioned that there's 5 or 6 moving parts in the system. They were all codified, with the exception of Postgres. They were all codified as containers within a single Docker Compose file. Now, what's really nice about this is not only is it a fairly lean, lightweight tool that's easy to use, it's incredibly easy to instruct people on how to operate it. So if you want your system up, you basically do Docker Compose up. If you want to bring it down, you basically do Docker Compose stop or Docker Compose down, right? That's the level of instruction that we had to provide to our customers because, again, not technical people. Getting SSH access to a server was already a process with that group, right? Again, not because they're stupid. It's not their job. It's not their expertise, right? They work in R, not in the terminal. And it was reusable for testing. We ended up using the same Docker Compose file in the production environments at our customers, in QA environments, in testing environments, load test. Every single thing we did was based off of this one single unified Docker Compose file. And that made things way easier because it meant that we were all kind of seeing the same coherent picture of the system, right? We were all operating the system in the same way. We packaged this Docker Compose file and the set of containers inside of a single VM package that we then actively sold and published on the marketplaces for AWS and Azure. Now, if you've never had the experience of having your system actually show up on a shop, any kind of shop, whether it's the App Store, Google Play, or even the AWS Marketplace, I highly recommend it because it's not only a cool experience to as a software engineer, to see your little piece of software being publicly offered, it also turns out that it's a really good user experience for your customers. Being able to go into their AWS account, go to the marketplace, and with a few clicks, have an instance of our system set up in their cloud account, made everything from the initial sales meeting to, oh wow, we're actually running in production and realizing value of the system, a 2-step, 2-minute process. Well, 4 minutes, because EC2 still takes time to start up an instance. But I mean, that's the level of frictionless deployment that we could provide to our customers just by virtue of using these tools. And that was amazing. We also asked our customers to set up, specifically mostly on AWS, an RDS instance for Postgres, which meant we didn't have to worry about authentication and authorization and retention and backup and all of the operational burden that is part and parcel of running an instance of an RDBMS server somewhere on an infrastructure. We didn't have to support our customers with that. Our customers didn't have to worry about it. It was fantastic. A bunch of lightweight scripts, tied it all together, really, really lean and easy. So, in conclusion, it turns out 20 years later, the tools that enabled the SaaS ecosystem to grow as it did, the tools that enable us to actually not have to do on-prem deployment for the most part, are actually every bit as useful and powerful in the on-prem space as they are in the SaaS space. Public clouds make for incredibly compelling on-prem deployment targets if you can get away with it. If not, then it is what it is. And in summary, I guess I would say that it's not your grandmother's on-prem, right? 20 years ago, delivering software was hard. 10 years ago, delivering on-prem software was still every bit as hard. Nowadays, I wouldn't say it's easy. You should still definitely go for SaaS if you can. But if you can't, if you are in the position where you have to provide on-prem deployments to your customers, it's almost a pleasure. Don't worry about it. Enjoy the ride. And with that, if there's time, I'll take any questions. If not, thank you very much for coming. Have a wonderful conference. Cheers.